Hi, welcome to this lesson on trigonometry, trigonometric identities part 1. Let's have a look at question 4. We're asked to prove the following identity and state any restrictions in the interval from 0 to 360 degrees inclusive, if there are any. Okay, so as always with identities, you have a left-hand side and a right-hand side, and you want to choose the side that's a bit more complicated if that's the case, and then try and simplify it algebraically using well-known trigonometric identities, and then making it look like the other side. So at first glance, the left-hand side has two fractional terms, whereas the right-hand side only has one fractional term. I see a tan on the right-hand side, which could be simplified using the quotient identity. Tan of theta, sine theta over cos theta. So I might be working with both left and right-hand sides to just get sines or cosines, or a combination of them. All right, so I'm going to start with the left-hand side first. Okay, so that's equal to 1 over 1 plus sine theta plus 1 over 1 minus sine theta. Now, when you add or subtract fractions, you always need a lowest common denominator. In this case, it is the product of the two denominators, 1 plus sine theta times 1 minus sine theta. Okay, but we can simplify that if we expand those terms out in the brackets. This is actually the difference of two squares, so we'll get 1 minus sine squared theta. But that is a very famous trigonometric identity that becomes cos squared theta, because sine squared theta plus cos squared theta equals 1. Okay, so what I'm going to do now is multiply both of these fractional terms by the LCD, which in our case, when we multiply the numerator here, it's going to be 1 times 1 minus sine theta, times 1 plus sine theta. Okay, all over 1 plus sine theta. So that's the first term. I multiplied the top by 1 minus sine theta over 1 plus sine theta. And then at the bottom, I need to multiply this 1 plus sine theta. This will become the LCD. So it becomes 1 plus sine theta times 1 minus sine theta. So that's the entire LCD. And because we only had 1 here on the top, okay, so let's just correct that over there. Okay, so because we have the LCD here, what did we multiply this fraction by to get 1 plus sine theta times 1 minus sine theta in the denominator here? Well, we multiplied the numerator 1 by 1 minus sine theta. Okay, then there's a plus sign separating them. Then again, it's this 1 times, well, it's going to be 1 plus sine theta. Right, because that's what we needed to get the LCD term. At the bottom, we need to multiply by 1 plus sine theta. And then 1 minus sine theta is already here. Okay, so that is the combination of adding those two fractions together using the lowest common denominator. So let's simplify now. So if I expand that 1 out, I get 1 minus sine theta plus, and if I expand that 1 out, I get 1 plus sine theta all over 1 plus sine theta times 1 minus sine theta. Okay, so now can you see that there's a negative sine theta and a positive sine theta? So those are going to cancel with each other, and you're left with 2 over. And then what I can do is, I know if I expand that denominator out like I did here at the LCD, that becomes cos squared theta. Okay, so I've just got one fraction term with one trig ratio cos here. Now this almost looks familiar to the right-hand side. So that means we're going to have to do some manipulation on the right-hand side to achieve equality. Okay, so let's write out the right-hand side. And doing so, I'm going to use the quotient identity on tan theta. So it becomes 2 times sine theta over cos theta, all divided by sine theta times cos theta. Okay, but I can rewrite this fraction now. So on the top, it's 2 sine theta over cos theta. And dividing by this term here just means multiplying by 1 over that term. That's what division means here. It's just multiplying by 1 over that term. Okay, so now the sine thetas will divide into each other. So I have 2 times 1 in the numerator, and in the denominator I have cos theta times cos theta, which is cos squared theta. So I've achieved equality here. I've successfully shown that the left-hand side and the right-hand side are equal. So therefore, this is a valid identity. Now, in terms of restrictions, again, when you're looking at restrictions on certain functions, you want to look at each function and see what will give us problems. So first of all, I identify that there was a tan theta term on the right-hand side. So where does tan have problems? Well, at its asymptotes. So that means theta cannot be 90 degrees plus any multiple of k times 180 degrees, where k is an integer. Okay, because at 90 degrees, that becomes an asymptote. On the left-hand side, I had a denominator term, so denominators of 1 plus sine theta and 1 minus sine theta. Now, denominators, we know that there becomes a problem when you have division by 0. So therefore, that means we cannot have 1 plus sine theta equals to 0, and we cannot have 1 minus sine theta equals to 0. So again, this is solving a trigonometric equation now. So if I take this first one here, I'm going to get sine theta. So I'm going to first solve the equation and find which values give us 0, and then those are the values that we cannot use. So for the first one, I get sine theta equals -1, and for the other one, I get sine theta equals +1. So again, for my cast diagram, okay, when is sine positive or -1? Well, we know at 90 degrees, sine of theta is 1. And we know at 270 degrees, sine of theta is -1. Okay, so therefore, the solutions for the restriction are as follows. So let's go ahead and make some space over here. Okay, so I'm just going to remove this. We've already proven that it is true, this identity. Okay, so for these equations here, okay, for sine theta equals 1, theta is going to be 90 degrees plus k times the period of sine is 360 degrees, for k is an integer. And then for the -1 solution, it's going to be 270 degrees plus k times 360 degrees, where k is an integer. Okay, so those are the two solutions. And then also on the right-hand side, which we should have mentioned as well, so let's just go back there. On the right-hand side, tan theta is a problem with the asymptotes, but there's also another part with the right-hand side, and that is namely that it has a denominator term as well of sine theta cos theta. And again, we want to find when is that equal to 0, because then those solutions will give us undefined, which will have division by 0. So by the 0 property of algebra, if you have two factors multiplying giving it to 0, that implies that one factor is 0 or the other factor is 0. So again, two more trigonometric equations we need to solve. So when is sine 0? Well, again, if I just go to the basic parents' way for sine, it's at 0, 180, and 360 degrees. Okay, so actually what happens is every 180 degrees, there's going to be a new 0. So I can just write this as theta equals 180 degrees times k, where k is an integer. That'll give me all the zeros on sine theta. Now what about cos theta? So again, cos theta looks like that. Well, it's at 90 and 270. So theta equals 90 degrees plus k times 360. Or theta is equal to 270 degrees plus k times 360. So those are the solutions for those two trigonometric equations. Okay, so all these equations that we found here, these are when we have division by 0 for the fractions. So we just need to plug in k values and see which values in this given restriction domain here will we have problems. Okay, so first of all, the tan theta one, that means every 90 degrees and every 180 afterwards are issues. So the restrictions would be theta cannot equal 90 degrees, theta cannot equal 180 plus 90, that's 270 degrees. If I add another two multiples, I go over 360. And if I start subtracting 90 minus 180, that's -90, that falls outside of that domain 0 to 360. Okay, so I've exhausted all those solutions. What about these ones here? Well, if I put k equals 0, I get 90 degrees again, which I've got. And if I put k equals 0 here, I get 270 degrees, which I've already got. And then adding or subtracting any integer multiple of 360 is going to go outside that domain. So we've exhausted all these restrictions. And then lastly over here, when I put k equals 0, then theta cannot equal 0 degrees, because then that'll give us an issue. Then we'll have division by 0. And if I put any other multiple, I can see if I put k equals 2, that means theta cannot equal 360 degrees, because then that'll give us an issue for division by 0. Okay. All right, so I've exhausted all the solutions here because everything else will be outside of 0 to 360. And then lastly, for cos theta equals 0, here we have the 90 plus 360 or 270 plus 360. These are exactly the same as these two solutions here, so we've already exhausted all of them. So the restrictions are 0, 90, 270, and 360 degrees. Okay, that'll give us, and then k equals 1 here. Almost missed that one. That'll give us theta not equal to 180 degrees. Okay, so essentially it's 0, 90, 180, 270, and 360 degrees. Those will be all the theta values that will give us a problem if we try to plug it either into the left-hand side or the right-hand side. Okay, I'll see you in the next one.